Welcome to my work solutions for the AQA Higher GCSE. As you can see, it's the summer 2024. It's paper 3, so calcs at the ready. Let's get on with it. Question 1, I'm not explaining that one, not wasting your time. On to part B. You're told that n squared plus 4 needs to be greater than 500. Now you can do it by trial and error. For me, because it's a calc paper, start with the 500, do opposites. Take away the 4 and square root it. You'll see it's 22.2. So 22 is not big enough. 23 is the first value of n where it will go above 500. Number 2, it's quite common on AQA. They do it here in Pythagoras and they do it later on in the sine rule, that they basically tell you the rule to use. Great, let's get on with it. Square both sides. We want the hypotenuse, so you need to square root the two sides squared and added. The way the mark scheme's phrased, they do like that 1,537 shown. So if you're not in the habit of showing that, I'll be honest, you should be. But if you're not in the habit, get into it if you're doing the AQA paper. It ends up at 39.20459. They don't tell you how accurate they want it, so do it sensibly. I'll choose one decimal place if I'm given the options. Number 3, sampling. So Rick's got 8 floors in his building and samples floors 1 to 5. There's your problem. So in any words, there's lots of different answers, by the way. You can get bored looking at the mark scheme. The one I'd go for is he needs people from floors 6 to 8. If you want to get overcomplicated, heat rising and all that, I wouldn't bother. Don't bother with that. Stick to needs people from 6 to 8. Why'd he stop? Is he scared of stairs or the lift's not working? Who knows? Number 4, you're told it's an identity. And obviously if you expand those brackets, you get that. And if you still aren't sure, pick a value for x, 0, 10, a billion. Who cares? It's always identical. Number 5, I'm rubbish with technology, so as you can see, I've drawn it already. If the volume is 42, the 2 dimensions you're being shown multiply to make 6, so you'll get the 3rd dimension to be 7. That's it. Always use a ruler for me. 6A, we've got Lars, nearly said Larry. Lots of different ways of doing this, and you can do it in any order you want. The way I go for it is, well, we've got meters, kilometers, seconds, minutes. So it's all about making sure you know where you are in terms of what units you're working in. So my first thought is consider that in meters, and then look at the relationship. 1,500 meters. How many times further is it than 50? And the answer is it's 30 times further. Well, if it's 30 times further, it will take him 30 times longer. And that's in seconds. So this answer of 1,200, also in seconds. To convert to minutes, divided by 60. And hey presto. Part B, another AQA tick box. In fact, Lars swims at a slower rate, so he's swimming at a slower speed, but he's still doing the same distance. That means he needs to swim for a longer period of time. It needs to be greater. Number 7, as you can see, yes, I've drawn it already, but let's explain what the heck I'm doing on top. And what I'm doing on top is reminding you that they've basically given you the option. If you prefer going these y equals mx plus c, you could go about this in that version where the gradient is the number next to x, the intercept is the number on its own, and there you go. So minus a half means for every 1 unit across, go down a half, or if it's easier, along 2, down 1, and you'll get your staircase and you can join them up. Or you might prefer to go for your table of values. Now, if I was designing a table of values, because of the half there, or minus a half, if you want to be a pedant, I pick even values so they're easier to halve. So when you sub them in, mental arithmetic or calc, you generate your coordinates of 0, 1, 2, 0, and 4, minus 1. Get a ruler, join them up. However you go about it, it's all good. Number 8, there's no actual questions on this page, but there is an idea of what's going on. So we'll come back to the question. Let's do some working out. Amy's total score is found. Find the mean and times it by 4. So you add up all her judges' scores and then you divide it by 6. All that will need multiplying by 4. That's done on the next page. Let's do the next bit. We're also going to need her percentage of the phone vote. Her percentage is, well, what's the fraction of her phone vote? She got 162 degrees out of a possible 360. That's the fraction. Turn it to a percentage by multiplying by 100, and these two calculations need to be added together. So for the final answer, you should have got 8.5 for her mean. That needs timesing by 4. And you should have got 45 for her percentage of the vote, of the phone vote. And we get 79 is Amy's overall score. Number 9, another one of them, conflict of units. They've put it in bold to be fair. You've got town B is square kilometre, town A is square miles. Let's look at town A. Town A, population density is population divided by area, but the area of 7 is in square miles. To convert miles to square kilometres, it's a multiplier of 2.6. That spits out 4,615-ish, 38 or whatever. It goes on. But B, as you can see, is 4695, which is about 80 larger. So town B has the greater population density. Number 10, we have a biased dice. Couple of ways of going about this. You could multiply them and take your answer away from 150. I go for the 150. So probability of a 6 is there, so not a 6. I always prefer the 1 minus approach. Helps if I write the correct number. Into your calc, 93. The other way, you'd have done 150 minus 57. You'd have still got 93, so it's all good. Number 11, who thought number machines and whatever, bit of simple bid maths would find its way onto a higher paper, but obviously they've got a little bit of a catch to them, haven't they? What is 10 divided by negative 2? It's negative 5. Your brain or your calc will tell you that. So how do we multiply negative 5 by a number and change its sign? You multiply it by minus 1. Down here, it's all multiplied. A third times 6 is 2. So we need something in this box that multiplies by 2 to give us 8. And we're going to need the pi from somewhere. Got to admit, I think that's a bit too easy for a higher paper, but there we go, even with the pi. Number 12, I think a nice bog standard. Probability tree diagram. There's nothing in the question. None of that waffle. Tells you that the numbers change for any reason. So there you go. Part B, what's the probability of at least one. So there's both gold, one gold, one gold. You could work out the probability of all three of those, add them together. It's on the calc paper. It wouldn't take you too long. But like I've already said, I'm a fan of the 1 minus that one. So it's 0.95 times by 0.95. You'll either get 39 over 400, or if you've done it decimal, 0.0975. Number 13, for your revision, the main thing is roots and solutions mean exactly the same thing. Your job is to read the points of intersection with the x-axis. The one up here, that's the easiest, 1.5. The one down here, get your eyes tested like I needed to. It's minus 2.2. No leeway allowed. All right, there's no halfway point. It does cross on a line. Mark scheme doesn't give any leeway. Number 14, a strange angles question. I'd follow through with the logic. You've got a diagram. It's not accurately drawn. So what? Put your label on. B is 45. Get it on. A to B is 7 to 3. So let's go underneath. So as you can see, B is on the right-hand side. So how do we get from 3 to 45? The multiplier is 15. Do 7 times 15, you get 105. So we know that the two left-hand angles add up to 150. So the two right-hand angles must complete the quadrilateral, must add up to 360. So x and y are 210. Show that a to y. Well, we already know a. The logic is we need to find y. Y is the right-hand number. So 4 to 1 means y is 1/5 of the 210. That gives us 42 degrees. We can now write our ratio. A is 105. Y is 42. Use your calc if you need to cancel them down, but the fact is you divide both sides by 21, and hey, you get your 5 to 2. Done. Number 15 can be done by Pythagoras, but I wouldn't. Get this line on. Ask yourself how far to the right is A to C. Going from -5 to 3 means it's 8. Going downwards, again counting, it's 16 down. Well, A to B is 1 to 3. In other words, A to B is a quarter of the journey. So let's quarter those movements. That'll be 2 along, 4 down. So 2 along from -5 takes you to -3. I say 2 along, let's be specific. 2 right from -5 takes you to -3. And 9 going 4 down from 9 takes you to +5. On we go. Work out the equation of the line which is perpendicular. So again, if you did Pythagoras, you've got to go back and realise it's the 8 and the 16 that will help with this, because the gradient of the line we've got is vertical change divided by horizontal change, -2. The gradient of the perpendicular, your teacher will have a variety of ways of describing this. I always go for negative reciprocal, so -2 becomes positive and 2 becomes a half. But some of your teachers might take you through the multiplies to make -1 root. It's all good, I don't care. You can use y minus y1 if you've been trained to do that. I'm going to stick with the y equals mx plus c. It goes through the coordinate 3 minus 7. So replace y with -7, m with a half, x with 3. Reach for your calc if you need to. That's 1.5. Subtract it from both sides. C is minus 8.5, or obviously minus 17 over 2, if you prefer. And your equation, mx plus c. And yet, I'm one of those people who's gone for fractions and decimals in the same. I'm one of them. Number 16, we've got relative frequency, theoretical probability, and so on. Tick a box. Well, the probability of a 5 here is 14 out of 72. That's 0.194 recurring. The theoretical probability, if it's a fair dice, is 1 out of 6. That's 0.16 recurring, which as you can see is less. So is the relative frequency greater? Those numbers on your page are needed, along with the ticking of yes for your 3 marks. Number 17 is a strange looking prime factor decomposition, which you could obviously work out the A and B by doing trial and improvement. At the end of the day, 2, 3, 5, 7, they're bound to be one of them. They can't be too big. But I would say don't be idle. Get the factor tree going. 10 times 20, that's 5, that's 2. And 20, if you want to speed the process up, do a 3-way split. 5 times 2 times 2. Didn't take too long, and as you can see, that means that A is 2, because it's 2 cubed, and B is 5. And you're there, aren't you? You just need to now work out 2 to the power of 4 times 5. So mental arithmetic or calc, 16 times 5, we get 80. 17b, tricky little multiple choice, but it's based on that knowledge that in order to be a cube number, the powers must be in the 3 times table. So we need to be multiplying, because you can't cube root c to the 4. Because if you do, you'll get c to the power of 4/3. You start talking about non-integers. Not what we're after. We need it to be a power of 6, and the lowest possible would be we need a c squared. If you multiply it by c squared, you get c to the 6. If you multiply by d to the 1, you'll get d cubed. You are then able to cube root it without going into non-integers. Or the long story short, it's that one. I said earlier, they tell you to use Pythagoras. Here they tell you to use the sine rule. So just crack on. You're wanting to treat a show as do it and hope you get the right answer. But show full working out. Don't scrimp on any lines of working out at all. All right, they can punish you if you just jump. If the answer of 64 comes out of nowhere, just do it the long way. Angles on top, because you're trying to find an angle. So sine x over the opposite is sine 35 over the opposite. I multiply both sides by 11. And you get 0.901, etc. Tell the examiner what you're doing. We're inverse signing that number. And we get 64.3, etc. degrees. And that's the minimum amount of working out I'd be comfortable doing for a show question like that. 18b, What's going on here looks very similar. I'm afraid not, folks. Take a good look at it. The 7 is opposite the 35. It's not here, it's adjacent. So without further calculation, is Anna correct? No, because the triangles are not congruent. None of your side angle or that malarkey are true. So stick that. I put A and B aren't congruent. Any words to that effect. Certainly don't be filling 3 lines, because if you have, you've wasted time. How do you find the f of g of 6? You find the g of 6 first. Stick 6 in, means you times it by 4, subtract 7. Applying BIDMAS or a calculator, you get 17. To do the f of 17, you stick it in and subtract 3. So composite functions just means work on the inside out. It's brackets inside brackets, basically. You work on the inside of the brackets first. Solve that. It looks complicated, all them brackets. It just means take the function of x, take the function of the f of x, and square it. Put it equal to the g of x. It's just a complicated way of saying, here's a quadratic, get it equal to 0 and solve it. Expand the brackets using whatever method you want. I'm going to square the first, square the last, times them together and double it. Now let's make it equal to 0. Subtracting 4x from both sides, adding 7 to get 16. These are numbers you might recognise, 10 and 16, because they're easy to factorise. We need a -8 and a -2, and to solve, change the signs. X is going to equal 8, and x could equal 2. Not as bad as it could have looked, it's just as straightforward. Get it set up, equal to 0, get it solved. Number 20 also doesn't look friendly. Definitely one of them, one thing at a time. P is directly proportional to Q. P equals a number times Q. P is 8 when Q is 2. Doesn't take a genius to spot that C is 4. So we've got a formula that P equals 4Q. Now let's move on to the slightly harder second part. R is inverse, so a different constant divided by Q squared. Replace R with 10. Replace Q with 3 squared. And we get K equals 90. So that our formula for the inverse proportion part is that R equals 90 divided by Q squared. Now, if you wanted to sub one into the other, you can. I'm not going to. Work out R when P is 0.5. Let's sub in 0.5 here. When P is 0.5, Q is 0.5 divided by 4, which is an eighth, or 0.125. And over here, in it goes. R equals 90 divided by 1/8 squared. Into your calc. 5, 7, 60. Logic, one thing at a time. Doesn't look as bad when you see it like that. Just plenty of little steps, really. Number 21. One of them which looks like it's tough to start. I haven't been given any numbers, you might say. Doesn't matter. Trust the process. Get on with it. Everything cancels. because that's how they do it. It says volume equals. Well, we don't know the volume. Get that worked out first, earn an easy mark. It's pi times the radius squared times by the height. It just is what it is. There's nothing really to replace from the standard formula. We need to put those equal to each other because the volume of the cylinder is equal to the volume of the sphere. Like that. And as they always do, the pi's cancel, but also you can divide both sides by r squared. So you end up with h equals 4/3 r. Because r is written first, I'm going to flip them around and multiply both sides by 3. So here's one way of writing our equals. So equals 3h. Or if you wanted to go again, and depending on how you've gone about it, you could also write that r equals 3/4 of h. As long as you remember, for your answer, r needs to go first, h comes second. Your answer, by the way, is not 4/3. It's 3/4. It's the other way around than what you'd expect. And yes, it could have the decimal equivalent of that. Why is it the other way around? Well, think about the bottom equation, for example. R must equal 3/4 times h. 3/4 times 4 is 3, which is why it works. And you can check it with the other one as well. So you do need to flip them around. So flip them around is the easy way of thinking about it. Hopefully I've just gotten across why. A different cylinder. So what's going on here? Well, the radius has been trebled. But in the formula for a cylinder, we square the radius. So it's times 3 and times 3 again. Height is doubled. It's times by 2. Ultimately, its volume will be multiplied by 18. Number 22, we have a 4-digit code. So combinations, permutations, etc., etc. Each digit, so order is important. She's only picking odd numbers. So 1, 3, 5, 7, 9, 5 possibilities. But no digit is repeated. So there's only 4 options, 3. And by the time you pick your 4th digit, only 2 options. Get them multiplied for a damn easy 2 marks. Number 23. If you can't picture it, if you've got a line of symmetry, quadrilateral on the left-hand side, so that's A, B, C, D. If you reflect it, it'll reflect over here. A and D will move out wide to the right-hand side, but B and C will stay on the mirror line. And staying where you are means something doesn't change, which means it doesn't vary, which means it's invariant. 2 stay the same, 2 change. And finally, could have been worse, I'll be honest. Not the worst, but not the easiest, completing the square. I only take the 2 out of the x squareds and the x's part. I leave the plus 7 alone. Complete the square inside. So x minus 3 all squared. Square the negative 3 and take it away. And now expand the square brackets. So we're going to get 2x minus 3 all squared in our answer. But we're also going to get 2 times negative 9 is negative 18. But add the 7, simplify your constants. You end up at negative 11. And there we go. all 3 papers done. Hope that's helped. Hope my explanation for how that was done did help. But if in doubt, just flip them around. But there we go. So there's paper from 2024, all 3 done. See you on the next one.